Yes, this is a Christmas tree. And right deep inside there, that's the BOP stack on the BOP skid. So these are the kind of enormous equipment that we use drilling subsea. And these are the equipments that we'll be reviewing throughout this period. Good day, everyone. Welcome once again to the in this video. We'll be speaking about numerous subsea equipment that we use to deliver subsea wells. As we proceed, please do not forget to like, share, and most especially click on the subscribe button. The outline of our video is going to be as follows. We'll be looking at the wellhead template, looking at the temporary guide bays, looking at the permanent guide bays, looking at the subsea wellhead system, casing hangers, seal assemblies, weir bushings, and protectors. So these are pretty much the equipment we'll be looking at running through this outline. If you're wondering what this video to the right looks like, that's a remote operated vehicle having its light directly on top of the temporary guide bays, and that's the wellhead system protruding from the temporary guide bays. These are the sort of equipments we'll be looking at individually. So on this next slide, the first equipment we'll be looking at is the wellhead template. It's used mainly for cluster drilling. That's where many wells are planned in a particular location. So these are as you can see, these are different slots meant for different conductors for different wells. The control and production facilities are well enhanced. Why? As you can see, it's well laid out, and that way, everything can be aligned. Everything can be aligned and well placed. Used with the mud line suspension system, and of course, it can also be used with the tieback system. To get a better view of what the wallet template looks like, this is exactly what it looks like. Here we have more slots, unlike that we saw on the initial picture that we saw. So here, this has more than 12 to 15 slots on a particular template. So the next piece of equipment that we'll be looking at is the temporary guide bays. Some in grad schools, one of my lecturers will say is not so temporary because sometimes when it's run, or most times when it's run, except it's an exploratory or appraisal well, most times if the development well, all the development wells I've participated in that it's been used to drill, it's never recovered. So it has 4 attachment points for the guidelines. That's pretty much what you can see here, and it has lifting eyes that are used to lift it during mobilization, and of course while it's being prepared to be run. It has compartments for dead weight storage because it's pretty much not as heavy as as it should. So while we are lowering it down, buoyancy acts against it. So sometimes you need some dead weight to be able to lower it down to the seabed. Then it has some anti-rotation spikes on the side. That's pretty much what you can see here. So that once you have the low pressure wellhead housing into it, it pretty much locks it in. Then a funnel style gimbal receiver at the surface, which you pretty much see here. So what you see here is that funnel gimbal and this is the low pressure wellhead housing sitting in it, locking itself in place. The next piece of equipment we'll be looking at is the permanent guide bays. It's not TGB actually; it's the PGB, similar to the TGB, and it's lowered with the first piece of casing. That is the conductor or the foundation pile, or what you might call the conductor. So, to explain the permanent guide bay, which is what you see here, we have used this sequence. So first of all, we have the temporary guide base lowered. Then after we have the um, temporary guide base lowered in, we have lowered the utility guide frame with the drill bit and the hole opener. It's inside here at the moment, drilling the required hole section and opening up. Let's assume we have a 16-inch bit or a 17.5-inch bit with a 36-inch opener. So it's drilling that, opening it all up. Then after that is done, on the next frame here, you can see your guide frame with the bit coming out. And when it comes out, the next thing is that we're going to run the permanent guide base and the first conductor pile, or the first conductor casing. So it's going to go in, it's going to land, and it's going to latch on here. So this is how we use the permanent guide base structure to lower the first conductor pile. The next piece of equipment we're going to talking about is the subsea wellhead system. So it comprises of the low pressure and high pressure wellhead system. So most times the low pressure wellhead system is about 30 inch, while the high pressure wellhead system is usually 18 three quarter. Um, because of how complicated subsea operations can be, it's been standardized, which we can see is the first thing we have here on the line. It's standardized respective of manufacturer, be it vertical gray, be it drill quip, all the producers of this equipment kind of make it standardized so that it can be run on any rig, and you can run it with any piece of equipment. So it's all standardized, making it easy across board. It is designed to support the weight of the BOP stack and the marine riser, piece of equipment that we'll be talking about subsequently. It's also designed to support the tubing hanger, completion, and Christmas tree systems. So sticking up here is just to explain that a little bit. Sticking up here is here the high pressure wellhead system. Sorry. So sticking up here is the high pressure wellhead system, which will carry the blowout preventer during operations, and post drilling, when we recover the blowout preventer, it will also carry the the Christmas tree. So it has a system, the H4 connector, which sits on here and is going to latch on and have that good seal, the good hydraulic seal that we need. So it should be able to be used on any rig, well terminated with a common wellhead interface at the seabed. That's pretty much just what I spoke of. So during operations, you have the blowout preventer. During post operations, when completing the well, you have the Christmas tree latching on this same system. It's able to withstand severe bending stresses and will consist of the high and low pressure wellhead housing. I just spoke about that. It acts as the pressure containment and mechanical interface between casing strings and the BOP stack. So, in summary, what we are saying in this outline is we have a good system here that acts as a good containment, good pressure containment, and it's built in a standardized manner, irrespective of the manufacturer, to be able to carry the blowout preventer and the wellhead system and the Christmas tree post operations. So this is a split of what it looks like. A lateral, as you're looking at it, lateral split of what it looks like, the vertical section of what it looks like. So it's pretty much the same thing, but this is a drawing and this is a picture. So again, repeats itself, standardized wellhead body, um, made using the API spec 6A, uniform working pressure across board, has metal to metal seals for good pressure containment, reliable seal assembly run and being retrieved, has an optional seal assembly lockdown. Then designing these systems is ensured that there is very minimal rotation and there is minimal tools running. So these tools, when they go in either to run or retrieve anything, there's minimal rotation. It's jading to run and jading to receive. So it's down there. So it's made in such a way that the turns are minimal for you to j into the particular equipment you want to recover or the equipment that you're trying to release, and it's easy to run and recover. Yeah, so this is conductor with the low pressure wellhead system. That's the 30-inch. That's it here. What you can see here in blue, and that's also what you can see here in gray. So it's here. Then you have the high pressure wellhead system. That's the 18 three quarter. It's high pressure, while this is low pressure. Then this is the one that the BOP and the Christmas tree will sit on. Then in the system, you have grooves for your different casing hangers. So you have this one, the deepest one, carrying the 13 and 3/8. That is after drilling the 17-inch hole section, 17 and a half inch hole section, or the 16-inch hole section. You run your 13 and 3/8, and you have this hanger hanging off. Then after that is done, you put your seal assembly. Then next whole section drilled, 12 1/4, most likely. You have your 9 and 5/8, and that's the hanger hanging it off, so it has this groove. Then finally, maybe you might drill an 8.5 inch hole section to the reservoir. Then you have the 7 inch casing. That's the groove for it there. It lands in, and perhaps post completion, or when the well needs to be abandoned. I mean, when the well perhaps it's abandoned, you have your temporary abandonment cap up there. So everything designed in such a way that you have good seals, and the pressure is, if any pressure from within down there, is well contained. So breaking it into pieces and taking this equipment one by one. Here we have your 30-inch low pressure wellhead housing. That's what it looks like. That's a drawing of what it looks like, and that's it being highlighted here. Um, the wellhead system usually 18 3/4 standard against the 21 1/4 and 13 and 3 for, I mean, for, or 13 5/8 for the dry systems, that's for the dry trees. So here it's standardized is 18 3/4, and that increased bore gives us more size for completion design options, and very less susceptible to thermal expansion of casing strings, and mechanically isolates the 13 and 3/8 casing string. So it's pretty much locked down to the conductor housing using either spring loaded lockdown dogs or snap rings. And sometimes we can also use split lockdown rings and also spring loaded segments. So each of these systems we've mentioned that is used to lock in this low pressure lead housing, that's the spring loaded dogs, the snap rings, split lockdown rings, and the spring loaded segments, have all proven to be very reliable, ensuring that the low pressure lead housing never disengages from the conductor. The next piece of equipment we'll be talking about is the high pressure wellhead housing. That's the 18 3/4, what you see up here. So looking at it in the diagram, that's it being highlighted here. It's just the piece of equipment that carries it. Just to talk about it in summary, is the piece of equipment that carries the all the high pressure systems. That's the blowout preventer and also the Christmas tree. The blowout preventer during drilling operations, and the Christmas tree post operations. So this is the breakdown of some of its characteristics. When landed, you can confirm that it's landed and fully latched on by. You can confirm that with an overpull. Um, it's very economical because it's pretty much standardized across board, and the running tool is normally a cam actuated or threaded design, so it's easy to land it, lock it in place, use that cam actuator to land, set, and release. So the next piece of equipment that we'll be speaking about is the casing hangers. I mean, I spoke about it. I spoke about them 2 slides before this one. How we hang off our casing joints, the groove already made prepared in the high pressure wellhead system. They're already prepared. Once you run the 13 and 3/8, you have the hanger at the end, so it lands into the groove. You drill the next hole section, which is your 12 1/4. Run the 9 5/8. The hanger is made up to pretty much to the last casing. When you land out, it lands off in the groove before you drill the next hole section. However, before you drill the next hole section, we will need to protect those grooves, which is the piece of equipment we'll be talking about in the next slide. So I'll take the sequence again. After you drill the um 17.5 inch hole section, you will run the 13 and 3/8. But while you are drilling that 17.5 inch hole section, you have an equipment called the nominal C protector that protects that groove, so that when you come post drilling this well to land the 13 and 3/8 housing, you still have the profile intact, so that when you land it, it lands off and it seals. Then after that is done, you set the seal assembly, completely isolating that groove before you drill the whole section. But again, before you drill that next whole section, you have to run a piece of equipment. Well, that is the wear bushing, just like that for the land operation. So you run that wear bushing, isolate that profile, drill the next whole section, retrieve your wear bushing, run the casing, land and lock it up in the profile. So, talking about the hanger system, the casing strings provide support of support to the formation, so it helps to ensure that the formation drill does not collapse. However, the casing strings are suspended by welded hangers, and even though they are suspended by welded hangers, the load is transferred from the welded housing at each hanger to series of the load string. So what it's saying in summary is the load from the 7-inch hanger is transferred to the 958, which is transferred to the 13 and 3 before it's transferred to the wellhead. So because we will be cementing most of this casing, that load, the cement in the annulus kind of takes away some of that load. That um, the interaction of the bonding from the cement, from the casing to the cement, kind of neutralizes the tensile load, because most times the strings are kept in tension when we run them. The cement from the in the annulus, when bonded to the formation, takes away some of that load. But however, all that load from the last casing joint run is transferred to the shallowest casing run before it gets to the wellhead system. So this is the seal assembly. After we run the hangers, we will run what's called the seal assembly. After the hanger is run and it lands into the profile, there is still an open groove that you can still communicate with the annulus. So this seal assembly lands in place and isolates completely the annulus, so that you have a you have a full conduit to surface, so that when you pump anything, or when you put pressure in the system, it goes all the way from the top to the bottom of the casing string, and some of them don't go into the annulus of the system. So you put pressure or fluid, it goes all the way from the top to the bottom once the seal assembly has isolated that annulus. So that's the function of that seal assembly. So that is the 13 and 3 seal assembly being set behind the hanger, rather after the hanger. That's it for the 958 up there, and that's it for the 7-inch. So they just sit and help isolate that annulus. So that's what we have identified all here. Then finally, this piece of equipment I spoke about 2 slides back, that's the nominal seat protector, which comes most of the time, it comes with the system before we drill the 17 and a half or 16-inch hole section. Once we are done, you use this retrieving tool to get it out, run the casing, land the 13 and 3/8, lock the hanger in, set the seal assembly. Then you use this same tool to run the wear bushing. That's to run the 13 and 3/8 wear bushing. This is so that we'll be able to isolate while drilling the 12 and quarter inch section. So once that is done, you use it, recover it again, get it out on surface, then go ahead to drill the 12 and quarter. You run it, you run the 958, sorry, you run the 13 and 3/8, drill the 12 and quarter. After you drill the 12 and quarter inch section, you retrieve it before you run the 958. Run the 9 and 5/8 casing, land it, lock it in place. Then you install this seal assembly before you run the 958 wear bushing. So where this goes in before drilling the 8.5 inch section, and this is the same tool that you use to run it, and that's how we progress. So this pieces of equipment you see here are all useful, as they are used to protect. One thing they have in common is that they are used to protect that profile in the 18 3/4 high pressure wellhead system, where we have all the profiles where these hangers will be landing and locking themselves in place. So we've come to the end of the video. Thanks everyone. We'll have there will be a sequel to this video where we will be completing. We'll be talking about the rest of the equipment we need to be drilling subsea. Thank you so far for following up. Thank you for listening to all the lessons. We will be waiting on your questions. We will be waiting on your comments, topics you like to see, topics you like to see to be that you expect to be shared, and most especially follow us on all our social media handles. And ladies and gentlemen, please don't forget to subscribe. Thank you very much, and see you in the next lesson. Bye for now.